Okay, hello everybody. I'm going to discuss lesson 12, ASM book, STIM or SMC or of SOA. Um, what I'm going to discuss here today is the combinations of two different distributions, which is the conditional distributions of Poisson with mean equal lambda and gamma distribution, which is the mean lambda distributions. Okay, so what we want to know is what will happen when we have this combination of these two together here. Okay, so let's say, okay, just write this is combinations of Poisson, okay, Poisson and gamma distributions. Okay, so let's say we have, okay, let's say we just write, what the distribution, the n given lambda. So this is Poisson distributions. Okay, just we want to write what is the probability mass functions for the Poisson and what is the PDF for gamma distributions later. So which is lambda here is gamma distribution. Okay, another way to say that, when you look at the basic statistic, we always have the value of lambda. For example, Poisson with mean equal 4, or Poisson the mean or the lambda equal 3, for example. But let's say we don't really have one specific value of lambda, but we have a range, okay, which is distributed from 0 to infinity, which is full gamma distribution. This is what we try to what the two line here try to tell you. And we want to look at we want to get what will be the distributions, unconditional distribution of n, and we have the combinations of Poisson and gamma. And of course, the gamma in general, so we have two parameters, which is alpha and theta. Okay, we just write, the function, the probability mass functions for Poisson first, which is probability of n equal n given lambda. So this is equal to exponential power minus lambda power n over n factorial. Okay, which is n here can take value from 0, 1, 2, up to infinity. Okay, whatever the value here, up to infinity. And the gamma distributions, okay, because this is the continuous distribution, so we write in the form of f here, which is equal to, in general, so we have lambda, alpha minus 1, exponential power minus lambda over theta power alpha, gamma alpha. Okay, which is the lambda here can take whatever the value more than 0 up to infinity. So to get the unconditionals, okay, which is probability of n equal n, that's not given here. So we have to integrate this because this is unconditional and we are given what is distributions of that particular lambda. So you have to integrate, okay, from range here from what to what depends on the lambda distributions. Okay, so in this case here, the lambda distribution here is from 0 up to infinity. Okay, you just find the probability of n equal n given lambda and the f lambda d lambda. Okay, d lambda. Okay, so we just insert the value. Sorry, we just insert the equation, the functions here. Okay, which is, for the first one here is your Poisson distribution, which is exponential power minus lambda power n over n factorial, and after that you times with, okay, as lambda alpha minus 1 exponential power minus lambda over theta alpha and gamma alpha. Okay, so the main, because we integrate here, okay, respect to lambda. Okay, whatever not related to lambda, so we consider it as a constant. Okay, we can take them out from the integrations. Okay, which is, you can see that here, the end, the theta power alpha and gamma alpha here, gamma functions of alpha here, they are not, there's nothing to do with the lambda here, so we can take them out from the integration. So whatever is that, later we just time them. Okay, so we just n factorial and we have lambda alpha and gamma alpha. Okay, this is 1 over, So you integrate from 0 to infinity. So we can combine whatever the lambda and lambda here, right? So when lambda n times lambda alpha minus 1, when you time together two variables with the power we add them together. So we have n plus alpha minus 1. So, and same thing for the exponential part here, which is they combine them together. Minus lambda over theta. Okay, so the next step here, what we need to do here is we need to do the integration part. So the integration, what we need to do is we need to use the integration by using distribution. We try to match with distribution, and after that we integrate. We just try to match with the distribution, and after that we use whatever the relationship, especially whether they are the PDF from 0 to infinity, survival, or CDF. Okay, so we have 1 over n factorial. You just rewrite it again, whatever from the previous line. Okay, so when you look at this match with, very close match with distributions of gamma, right? So we have 1, when we factor the minus lambda, so we have inside the bracket we have 1 plus 1 over theta. Okay, so we can mesh this with gamma distributions. When you look at this is the pattern of gamma, right? It's much easier. So we have with the lambda value equal to n plus lambda. And we need to find what is the theta value, which is the theta equal to theta 1 plus theta. Okay, so when we have this as a theta, so you have to make it very similar to gamma distribution, which is the theta is theta over 1 plus theta, and after that you power with n plus alpha and gamma alpha plus n, because our alpha is n plus alpha. Okay, and after that d lambda. Okay, so because we don't have this, the bottom part here, this part here, we don't have this in our original. We don't have this here. So you have to cancel them out. Okay, you have to cancel them out to make sure that they are equal, right? Otherwise, you cannot get that equal to our previous line equations. Okay, so you have to cancel them out by times them. Okay, theta over 1 plus theta and power n plus alpha and gamma alpha plus n. Okay, when you look at inside the integrations, so this is gamma distributions. Okay, this is gamma distributions with alpha equal to n plus alpha, and the theta equal to theta over 1 plus theta. Okay, when you integrate the whole thing, okay, because gamma start from 0 up to infinity, if you integrate the whole thing from 0 to 0 to infinity, so of the PDF, so meaning that the whole thing equal to 1. So this part here, you get directly equal to 1. Okay, so it's really make our life easier here because we already get that equal to 1. So we just rewrite that again, whatever left, okay, after we already equal that to 1. So we have n factorial. Okay, and after that the other part here we have theta and so we have times with theta over 1 plus theta, so this is power n plus alpha, and after that gamma alpha plus n. Okay, so we can cancel some part out. Okay, so at the end what you will get is just alpha, okay, alpha plus 1 and alpha plus 2 and you keep time this, you know, up to alpha plus n minus 1, and you divide this by, okay, n factorial, and after that you times with, okay, 1 over 1 plus theta power n, and after that 1 plus, sorry, this is power alpha, and after that theta over 1 plus theta power n. Okay, I just brief it to you how actually we get this. When you look at this part here, okay, when you look at the theta power alpha and the theta here, okay, so you will cancel some, you can cancel the alpha theta, sorry, you can cancel the theta power alpha and the theta, and sorry, the theta power alpha at the top here. So that's the reason why you cancel that part out. Okay, so left you with, okay, 1 over 1 plus theta power alpha, okay, and theta over 1 plus theta power n for this one here. Okay, so whatever the n factorial here, which is you get it from here, okay, directly. Okay, so very straightforward, and we need to cancel out both of your gamma functions, yeah, and you know that the gamma functions, okay, I just write, you know, how actually you will get this. I just want to highlight that how actually we get this one here at the top here. Okay, so which is we divide, okay, lambda. So let's say I just write in this very small notes here to avoid your confusions. Okay, so let's say we have very small notes, okay, which is we divide lambda, sorry, gamma alpha plus n, and over gamma alpha. Okay, so we know that the gamma function, let's say gamma n equal to n minus 1 factorial. Okay, the bottom meaning factorial, so meaning that you keep times them up to what is the number. Let's say if n factorial, so meaning that 1 plus 2, sorry, 1 times 2 plus times 3 up to you times n, right? Same thing here. So you keep times 1 times 2 times 3, and you keep times that up to alpha minus 1, okay, because alpha minus 1, okay, because of gamma function alpha equal to alpha minus 1 factorial. Okay, and after that the top part here is 1, you times with 2, you times with 3, and you times up to, okay, alpha minus 1, but more than that, alpha, and after that alpha plus 1, okay, you keep time that up to the last one, which is alpha plus 1 minus 1. Okay, you can see that we can cancel because they are ratio, right, at the top and the bottom, denominator and numerator. So you can cancel this, all of them. Okay, so left you with, this is equal to alpha plus 1, and you keep time that up to alpha plus n minus 1. So this is how you get this one. Okay, this is how you get the top one here. Okay, so this is how actually you prove. From combinations of Poisson, okay, Poisson and gamma, and you will get negative binomial. When you look at this is how actually the negative binomial distribution will look like, with a bit difference because of the alpha is your R and your theta is your beta. Okay, so you can see that when gamma distribution with two different parameters, with alpha and theta, so your negative binomial, okay, with R and beta, so meaning that your R equal to your alpha and your beta equal to your theta. Okay, so this is negative binomial distribution with R equal to your alpha and theta equal to your beta. So this is how you prove that. Okay, thank you very much for watching this video.